And welcome everybody to the Daily Space Weather. To our regular viewers, you may notice some differences here. It's because we're not viewing our live premiere. We are streaming the video live instead. So this is going to afford us a little bit of extra time. Keep in mind, I'm not only Smash-O-Mash, but I am also a client. So anyway, slight difference here today in the format. This is a true YouTube live stream exclusive. And we're delighted to bring it to you because it's a hallmark day for CMEs. You may see some activity up here in the northwestern limb. Indeed, it is quite spectacular. And don't worry, we're no slouch with the fresh footage. So you may not notice any major differences here. It's just that we'll be able to interact with you, the viewer, during the video, and you'll actually be able to contribute to the content, theoretically speaking. So make sure you drop us a line. There is the northern hemisphere. Again, you can see a huge CME happening there as a massive filament makes its way out into the greater solar system. We'll talk about whether it's earthly directed a little bit later. Here it is in some other wavelengths. Here we've added 193 angstroms here to the 304 angstroms wavelength. Pretty freaking sweet. Also a partial eclipse happening there at the end of the video. You can see the moon sliding across the top portion of the frame there. Here's 335 plus 171 angstroms. And let's go back to 304 here for a minute, as there was a CME from the southeastern limb as well. We've also got the possibility of, you can see down here, some crown prominences, the possibility of a south polar solar vortex. The stage could be being set right now. Also a huge filament here right behind the Earth scale, and also you can see a Hyder flare happening right here as some of that plasma from the northwestern CME splashed back down all the way down here around the center portion of the solar disk. We'll let that play through one more time just to show that Hyder flare. Here it comes. And there is a bunch of plasma splashing back down into the chromosphere region, the area in between the photosphere where sunspots occur and the solar corona, which is the sun's, quote, atmosphere, end quote. Here is the eastern limb. Again, quite a bit of activity on the Earth-facing portion of the solar disk. It's an exciting day for space weather as major upticks happen. So here's just the northeastern limb by itself. A great close-up of some new sunspots there. And of course, see yesterday's videos for some amazing activity from these groups. They were highly underviewed, yesterday's content, so no real good reason why. They just were not very widely viewed. So here we're going to show sunspots. This is yesterday plus today. And we've had a small uptick in the radio flux. You can expect that to continue here as these sunspots move into the Earth-facing portion of the solar disk. So, yeah, no major changes here. I'm not so sure that I see anything new really happening. A little bit of degradation to this sunspot group. Looks like a new group might have formed right here. So mostly stable here with these sunspots. Here is the colorized magnetogram just for sake of completeness, as we bring you the world's most comprehensive space weather. And thanks for tuning into the Smash News Network, least busted name of news. Let's see what's going on Croissant Earth. It's the volcano rundown section. Today's volcanoes include, at least the erupting ones, Subinosejima exploded and produced an unknown volcanic ash plume. Please don't hang glide over the caldera. Mount Mayon continues to erupt. Unknown ash cloud there over the Philippines also. In central Mexico, Popocatépetl exploding. Flight level 220. It's a 22,000-foot ash plume. 20,000-foot ash plume over Colombia from Nevado del Ruiz. Sangay in Ecuador exploding. Flight level 210, 21,000-foot ash plume, 20,000-foot ash plume from Sabancaya in Peru as it also explodes Please don't pole vault the caldera. It could be unhealthful, and we need the views on YouTube. Next, and thanks for leaving comments, Sarita and Mike and Smash Staff. So here's the past 90 days, and it's been pretty active around the Pacific Rim in terms of seismicity. That's the last 90 days of earthquakes in a convenient bar graph form there from volcanodiscovery.com. And there was a 4.4 magnitude quake at California. We'll actually report on that one. That was early this morning at 3:44 Universal Time. So anyway, we're going to cite quakes over a 5 magnitude besides that California one. Again, quite a few quakes there around the Pacific Rim. And a quick public service reminder that any earthquake can be a foreshock. So remember, even a large earthquake could be a foreshock. Don't assume that the shaking is over. The shaking could be an indication of future earthquake activity. So starting out the list here, there was a 5.7 near Samoa. That was at 1844 Universal Time yesterday evening. It was pretty quiet up until that point, and then later in the night, 5.3 at Tonga. These look like aftershocks from a recent 7+ magnitude quake in that area. Also a 5.4 at 2316 yesterday evening. A 5.0 struck Ecuador at 9:10, and only 4 minutes later, a 5.0 struck Alaska. So thousands of miles away there, but only about 4 minutes apart. And thanks for leaving a comment, Damien Ablett. Evening, yes, good evening. As you are in the 6 darkest days of the year down under there in Australia. The 6 brightest days of the year here in Pennsylvania. Anyway, back to this 4.4 at California. Here's the location of that one. It's near Clear Lake. There's a location of that. That one was at 3:44 Universal Time this morning. And let's get back to space after we talk about the 5.3 at Vanuatu. That was the most recent quake at 9:59 Universal Time. And it's time to get back to space because we've got some more fresh imagery for you. There is 171 angstroms from the SDO. These are 24-hour videos, by the way, just like the ones we started out the video with. An active sun. If you're frightened of it, we hope maybe you're less frightened of it than an inactive sun. I don't know. People are frightened of a lot of weird stuff on YouTube, like contrails. Yeah, like contrails. All right, so the 10.7 centimeter radial flux now at 158 solar flux units. An uptick of 1, I think, from yesterday. There's the 1-year graph to put it in context. 10.7 centimeter radial flux is depicted by that black line there. And sunspot number looks a little bit low here. We're expecting an uptick in the sunspot number here. I think some sunspots might not have been counted. Let's move on to the Space Weather Enthusiast dashboard, which is forecasting some mild geomagnetic unrest throughout the day tomorrow. And we're forecasting the possibility of a CME impact sometime late tonight. So sometime between here and midday tomorrow, and a second CME impact sometime in around this same range. So through midday tomorrow, we're expecting the possibility of 2 possible glancing blow CME impacts. They'll be minor if there is any signal to be seen. And remember, folks, you're better off over-forecasting for such things than under-forecasting. Anyway, that's the current situation. It looks like NOAA may agree with us here. They're not really modeling very much, but they are forecasting some KP 3.67 throughout the day tomorrow. So tomorrow is a likely day to see some impacts. Again, expecting them to be minor. Let's take a look at Earth's magnetic moment from space next. This is our Geospace Magnetosphere movie. It depicts 4 hours if all is going according to plan, and it is. We're seeing a subsiding of a coronal hole high-speed stream. A quite slow and very, very diffuse solar wind is currently the situation. So again, that's the past 4 hours of Earth's magnetic moment from space. It's our magnetosphere movie depicting magnetohydrodynamic pressure. Earth's magnetic moment from the ground has looked like this for the past 4 hours. Again, we've got a very low density solar wind and quite low speed also. We'll cover it here, and we're going to let that play through as it refreshed. And it's always refreshing to see your comments and to be able to respond to them while making the video. So that's always a delight. Keep in mind, I'm not only Smash-O-Mash, but I'm also a client, meaning I usually watch these videos, but to save some time, we're now streaming them live. So that should be pretty cool for you, the viewer, as it should make the videos a little bit more interactive. Planetary K-index is currently at 2.66. 2.66 is the KP. Planetary K-index is an average of global geomagnetism. And let's move to the real-time solar wind. Again, extremely diffuse here. Only about 1 proton per cubic centimeter for the solar wind density. Solar wind velocity here below 400 kilometers per second. Pretty average there. Just, yeah, the coronal hole high-speed stream has subsided. So we should get a clear signal if we do see any glancing blow CME impacts as forecast. Again, the possibility of CME impacts begins late tonight and ends around midday on the 20th, Tuesday. Here are your GOES magnetometers, which are much smoother than they have been in previous days, of course, because, well, the coronal hole high-speed stream has ended. So here is the coronal hole high-speed stream, the initial density impact, and then there you can see it subsiding in the past 36 hours. That's 7 days. We normally show 3 days of GOES magnetometers, and there are the top view ecliptic plane field plot data from the National Solar Observatory. So this one's super important, and something very important to show here is this. So this north solar polar field here, it made its way down toward the equator, and then it popped back up toward the pole. So this is sort of the gateway to solar maximum. Once we actually see that magnetism leave and stay gone, there will be clear sailing to solar maximum. We are currently not at solar maximum. There is too much North Pole magnetism at the North Heliographic Pole, although you can see it slipping away and then popping back. So that is expected to snap down toward the equator really at any moment, as it has been there since the previous solar minimum. Next, our line of sight field plot. Here the sun's B field is depicted in blue. The grayscale is the Gong 2 magnetogram, and then the solar polar fields are in green and red for north and south respectively. And there is the coronal hole line of sight plot. So this is another interesting feature here. You're going to see a bunch of coronal holes suddenly appear there, right around the northern hemisphere. So that's probably not a coincidence that there's all that magnetic restructuring happening around the North Polar region. You're seeing the solar cycle process occurring on our channel every day. So we're going to get to sunspots next. Let's first briefly take a little look here at what's going on in terms of SDO imagery for coronal holes. These are all South Pole-oriented coronal holes, and they're very well defined in the 211 angstroms wavelength. It looks like we've got another situation down here which is interesting, as we've got a coronal hole here with an active region inside of it. Now, we shouldn't really say it's inside of it, because the active region is actually below the coronal hole. Keep in mind, coronal holes occur in the solar corona. Sunspots occur in the photosphere, 2 layers below that. So in between there is the chromosphere layer. And it's very interesting to consider what may be going on in the chromosphere when you've got an active region right below a coronal hole. So something's probably going on there. We've covered active regions below coronal holes in the past on the channel. And let's get the sunspots here, as that's kind of important, I would say. And I think we've got, let's see, there's at least one group that ought to get a name here in the northeast. That'll be 3340. And also another possible group up here. That'll be 3341 if that does get a name, if it's there long enough, etc. Let's take a look at some more detailed imagery here. There's a great close-up of the equatorial portion of the solar disk. And that is once again SDO continuum. So again, no major changes. That's a new sunspot group there. That one ought to get a name, I think. This one here will certainly get a name. That'll be 3340. We covered it yesterday. I don't know. There's a little bit of delay in naming sunspots recently. What's up with that? And let's move on to energetic particles and solar flares. So there's the ghost proton flux. No spikes in that, despite one decent-sized flare. The largest flare of the past 24 was this an M1.5. Let's bring up the 1 day just to get a little bit better resolution there. It was an M1.3 approximately. There's the 3-day graph. And let's switch to some wavelengths that are good at showing flares. Here we've added 131 to the 171 angstroms. And let's swap out the 131. Let's swap out the 171 with 94. And that flare occurred just after midnight. And I'm trying to figure out where it came from. Can anybody see where the flare came from? Was it here? I think it was this region right here. Let's subtract 131. Here's just 94 angstroms. Maybe that'll be more clear. And thanks for leaving a comment, MQPC and Fine Art Studio. Seriously, where the heck did that M-class flare come from? It's... Anyway, I won't dwell on it. Let's move on, as there's plenty more stuff to cover. First of all, if you like the content, please support the channel via our links. You can find the links on the homepage at smashomash.com and many of them below this very video. This portion is about our Hemp Lucid affiliate. Make sure you enter the promo code SMASHOMASH to save 10% on your checkouts for your Hemp Lucid orders. So when you're shopping at hemplucid.com, just on your checkout screen, enter the promo code SMASHOMASH. You'll save 10% that way. You can also find a link on our homepage at smashomash.com, so perhaps try out some of the products if you haven't before, things like mushroom gummies, maybe the body balms. What about some lip balm to protect your lips during those long summer sunny months? CBD for your pets, Delta 8s, and lots more. Enter the promo code SMASHOMASH to save 10%. Today's featured product is, on the Amazon store at least, it is the Korshield hat. It's a cycling cap, and I'm currently wearing it. So there you go. Ride bikes. I am a lifetime steward of the sport of cycling. So if you want to use some of the same gear that I like to use, you can find some items there on the Amazon shop. Amazon.com/shop/smashomash. Also linked on the homepage at smashomash.com. So visit our links. And by the way, I am not one of these cycling lifestyle people. I consider the sport a sport. Part of the reason why I ride fast, I've got other stuff to do afterwards. Today's featured merch item is the Project Management Facts Pick 2. It can either be fast and cheap but not good. Nobody wants that. It could also be good and cheap, but not fast, in which case it'll be slow. Or it could be like our videos, which are over here where the 1 is. Fast and good, but not cheap. Yeah, it's super expensive to put out this content. And it's super expensive to not understand these project management facts. Because if you're trying to make the job fast, cheap, and good, you are striving for an unreachable goal. So pick 2. Those are all you get with project management. The great colorful design here, one of our more recent Redbubble editions. Links on the homepage to the Smasho merch at smashomash.com, as well as below many of our videos. So check out the merch. They are designed to provide wisdom, or perhaps just rage. Project management facts. No project is cheap, fast, and good, so pick 2. No project is fast, cheap, and good. Next, we're looking at a star chart. This is what's going on overhead in Lehigh Valley. You've got Saturn and Jupiter and Mercury up there, but they're not visible because the sun is way too bright. Also, it's new moon day, so happy new moon. And if you are looking at the dusk sky, it's a great time to look at the dusk sky because you've got Venus and Mars up there. So Venus and Mars, the 3rd brightest object in the sky. And sometimes, depending on its location and comparison to Jupiter's brightness, sometimes Mars is the 4th brightest item. Next year's solar system forecast. Again, happy new moon to all my reverse werewolves. Congratulations on sleeping well, not cannibalizing humans, and being a happy, productive, normal, functioning member of society. Reverse werewolves, shout out to all of you. Here's your 1-week forecast for the solar system. That's where things will be in a week. And by the way, we're in the final 3 days of spring. So summer is, yeah, you get the idea. Winter is coming to the southern hemisphere and summer to the north. It's the 6 brightest days of the year right now, folks, for most of our viewers, except for those of you south of the equator. For you, it is the 6 darkest days of the year, the darkest days of the year. So here are our coronagraphs from yesterday, and 2 major CMEs happening there. You may be wondering if those are earthly directed. The answer is probably not. So those are yesterday's coronagraphs. That's 97 frames. We'll also show today's to date. There are an additional 47 frames from today. And you can expect the CME activity to continue, as there are plenty of active regions, very high likelihood of large solar flares, and lots of plasma filaments on the Earth-facing portion of the solar disk. So here are the SOHO coronagraphs side by side, C2 and C3. We'll show stereo A also. Feel free to pause the video on this frame if you're not familiar with the locations of things like the Solar Orbiter in pink, Bepi Colombo in orange, stereo A and B, etc. So here's stereo A on the left. Great imagery there of those CMEs. Bruce says, holy smokes, it's blowing up. Holy smokes, the brand the Pope smokes. Anyway, there are some CMEs, and let's cut to some custom CMEs. Some custom CME views, at least. Here are our 24-hour coronagraphs. And, yeah, that one was good enough to make the thumbnail today. And here's a little closer view. You can see that plasma moving around there in the SDO 304 angstroms wavelength in the middle. Here's an even closer view. Kind of a low-speed CME there, and it took quite a long time to propagate. Kind of ended up going some odd directions there. It looked like it was going to go way off to the northwest. Well, it largely did go off to the northwest. But it ended up a lot farther south than I would have expected it. And that's a great example of how CMEs are very unpredictable. Maybe there is a way to predict them, but we don't currently have that. As far as I know, the ability to predict the trajectories of CMEs as or before they happen, it would be nice to be able to. But at the moment, not so much. Anyway, there's just the northwestern limb, which is the site of the most interesting activity in the past 24 hours. That huge filament release has been spectacular. And we streamed it yesterday live, by the way, both on Twitch and on YouTube. So if you want to see that in the GOES 18 SUVI wavelengths, go view our live streams. Again, there was one on YouTube yesterday as well. So both of our major live streaming locations were lit up by that awesome CME activity. So here's just 304 angstroms all by itself, and we've come full circle. It's time for bonus features. So let's get to it, shall we? Filaments. Massive filaments on the Earth-facing portion of the solar disk. You can see them showing up here as dark absorption features. One of these actually already has a name. It's this one down here in the south. That's called the Cornell West filament, and it's quite huge. Shout out to our Twitter follower who named that filament. If you want to name filaments, follow us on Twitter. Follow the hashtag #NameThatFilament. Again, lots of filaments on the Earth-facing portion of the solar disk. Likelihood of coronal mass ejections remains at nearly 100%. Again, make sure you follow us over on Twitter. If you are doing the social media thing, if you've unplugged completely, we understand completely, because it is truly pathetic, a truly pathetic environment of ridiculous and nonsensical censorship of basic facts. Yeah, basic facts. They're very controversial. Still, even though it's 2023, it's no longer March 2020, folks. Facts remain controversial. Pretty putrid, wouldn't you say? Anyway, here are the past about 2.5 hours from the GOES 18 SUVI and 304 angstroms. And again, it looks like there's actually some more activity rising down here. So, yeah, it's fairly exciting. So here come bonus features, starting with satellite charging hazards. There are some minor ones here of the surface charging variety in the central Pacific Ocean there. That's a situation where low-energy electrons build up on the outside of spacecraft, causing those minor surface charging hazards. No big deal. And here's the GOES electron flux. We are in electron warning levels here, and this is often the case where we see high levels of electron flux. So electron storms are often a feature that follows coronal hole high-speed streams. There's a prime example of it. You'll see the electron flux was cratered here during the coronal hole high-speed stream, and then a big increase. So that is expected to last a day or two. Keep in mind, if we have a CME impact, it'll probably crater again. There's the one-year graph to put the electron flux into context for you. That's the greater than 2 mega electron volt electron fluence from solon.info if you want to follow it yourself. There is the forecast model. We didn't get quite as high as NOAA forecasted. NOAA expecting slightly higher levels tomorrow than today, although that might be revised. I wouldn't be surprised if it was. No arguments there on the electron flux forecast. Now that feature, this electron flux, it is measured from the geosynchronous orbits of the GOES 16 and GOES 18. These things are at about 23,000 miles of altitude. They're measuring the electron flux all the way down at the F flare. They're using radiography from their geosynchronous orbits, and they're measuring the free electrons down at about 300 kilometers of altitude. Keep in mind, when a geomagnetic storm happens, that electron flux is often erroneous. That's the cratering that we see, and of course the ionosphere puffs up when those things happen. Here is the ionosphere in vibrational frequency. It's the bridge between Earth and space. And this depicts megahertz. So this data is courtesy of the Australian Government Bureau of Meteorology. That's our ionosphere movie. We show it daily on the channel to create an archive of ionosphere data, because you never know when old data will suddenly become useful. So one of the many features of our daily space weather videos is that they're archiving massive amounts of data in tiny amounts of space. So the videos may seem long, but there are all kinds of uses here that might not be evident. So this is the anomaly in megahertz from a 30-day median. We show this as well. It does show 10 times more resolution than the raw frequency data. As you can see, it does go down to 1/10 of a megahertz there. So that is the anomaly in megahertz from a 30-day median. Let's show the latest image as we do. There's 13:15 universal time coming at you kind of late today. And 13:15 universal time anomalygram. Great example of the South Atlantic anomaly here. You can see that huge variation between high and low frequency anomaly. There's also another weak spot over here, not as weak, on the equatorial west coast of Africa, right about where my pointer is. We also show the total electron content, which is useful for GPS users, as it shows GPS errors. It's also useful for space weather enthusiasts, as it gives us insight into what is happening all the way from the ground level up to about 12,500 miles of altitude. So those are the free electrons from the inner Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere, all the way down to ground level. These are the most likely places to see GPS errors. It is what's depicted with the total electron content. We'll also show the total electron content anomaly from the 10-day average for North America. And if anybody is using this to forecast earthquakes, let us know, because I'm not so sure that it works, and I'm not so sure that it even comes from an impulse from space. It could be an Earth-side signal that appears in the space weather data. Either way, we are interested in it if it has predictive value. We'll close out the space weather section with our latest intensitygram and latest SDO magnetogram. Again, so here's a new sunspot. That ought to get a name. That is beta gamma class, at least. It could, I think it is beta gamma delta class. That is beta gamma delta class. Anyway, at least 3 of those other groups are also magnetically complex sunspot groups. As you can see here, that's beta gamma delta class, that's beta gamma delta class, that's beta gamma delta class. So there is a very high likelihood of continued large solar flare activity. What's up with this group? Oh, there's another new sunspot there. So we'll see. We should see 2 or 3, maybe even 4 new named sunspot groups today. If you were banking on the sun shutting down, you've done some bad banking. Cash in those assets before they completely crash off a cliff into a crater straight into your bunker, because the sun is clearly not shutting down. And let's move on to our meteorology segment. Now, we used to put our meteorology segments in separate videos. We used to compartmentalize all of our space weather videos. We had regular space weather, bonus features, and so on, and guess what that did? Gave us less views on YouTube. So we've ended that promptly, instead putting all the content together in one place. So what we're currently looking at here is the hottest place in the world, which is someplace north of Saudi Arabia here. It's like 118 degrees up there. Yeah, that's the hottest spot, I think, right? 119 Fahrenheit there, hotter than the Sahara Desert, and frankly, hotter than any place in the world. The coldest place in the world, not surprisingly, as winter approaches, looks like it's right there at negative 67.6. That's on the cool side. Negative 69 degrees Fahrenheit. On the world's highest and driest continent. Did you know Antarctica is a desert? Yeah, Antarctica. It's the driest place in the world. Water, it doesn't like being that cold. Anyway, let's switch to our regularly scheduled meteorology segment. There are the wind maps. The surface wind scenario for the eastern world. Several low pressures there, including one in the southern Indian Ocean. and one pushing up against Tasmania. Shout out to Dirk, who must be having some stormy seas. Here are the jet streams of this side of the planet. Shout out to our viewers from the most populated portion of the planet right here. There's like 3 billion people inside that small circle. And let us know in the comments if you think the Earth is overpopulated. If you think the Earth is overpopulated and you've never left the city, you should. There is a lot of empty space on planet Earth. Anyway, there's also a lot of unexploited natural resources, by the way. Anyway, here are the jet streams of the Western world. Getting a little bit more coherent jet streams over the U.S. And a strong anticyclone here over southern Mexico. It is a high-pressure heat dome, most likely. Here are the surface winds of the west. Strong onshore winds at Central America. Here are the surface winds of the European and African and Central Asian part of the planet, the Middle East. And there are the jet streams. Continuing on to our drought map. We talked about it a little bit yesterday in our live premiere. So there is the drought map. And, you know, we were laughing yesterday because Pennsylvania just came out of extreme drought conditions. Pretty much the whole state was in extreme drought conditions, and now most of it is not in extreme drought conditions. The local newspaper reported on that like 2 days ago after it had already ended. So a prime example of, let's see, not fast and not particularly good and not particularly cheap either. That newspaper is owned by the Tribune Company, if you're wondering. Anyway, that's the U.S. drought map. The Yucatan Peninsula is in extreme drought. Also parts of Minnesota. But a lot of the drought has subsided across the U.S., so that's a good thing. Let's take a look at clouds and fog here as we zoom in closer and closer to the weather of the United States. So there is clouds and fog over the Americas as the Gulf states get pummeled once again with extreme weather, extreme heat, and extreme storms. Also freeze warnings there in southern Oregon and freeze watches in northern California. It's almost summertime, and they're getting some wild temperature variations there across the U.S. That purple portion of Oregon there, those are freeze warnings on the 18th of June. So since temperature is showing up in the warnings, here is your temperature forecast based on a GFS 72-hour model. Temperature is expected to reach 113 degrees in southern Texas. Yeah, 113 in the forecast for southern Texas. Next, the temperature anomaly and the northwestern part of the country having come out of extreme heat. Now it's going into extreme cold, expecting temperatures 16 degrees Celsius below normal. That's your GFS 72-hour temperature anomaly forecast in degrees Celsius. So some wild temperature variations across the country here, including some huge temperature swings in central Texas, from low to high temperature anomaly and so on. Pretty berserk. Last but not least, we'll show the GFS 72-hour pressure and precipitation forecast. Snow in the forecast there for Washington, Oregon, Idaho, Montana, parts of Northern California, and Nevada, it looks like. And extreme weather here forecasted again for Missouri, Kentucky, etc. Anyway, you see the map. That's why we put it up. It's the 72-hour GFS pressure and precipitation forecast, courtesy of tropicaltidbits.com, as stated. Next, our lightning mapper. And, yeah, major lightning storms there, especially in Oklahoma and Arkansas in the past 10.5 hours. And here's a real-time lightning map, courtesy of lightningmaps.org. I do have some significant thunderstorms here happening in the Gulf states as they get hit over and over and over again. Shreveport, there's thunder rolling in. There is an extreme thunderstorm, which is mostly to your north and moving mostly to the east. So there you go. That's pretty sweet. And of course, the weather portion of these videos is way better when we do it live because it's as real time as it gets. There's no issues with processing the videos and uploading them and waiting for a 15-minute interval of time. There it is. It's real time. It's live. Cheers. By the way, if you enjoy the content, don't forget to support the channel via our links. You can find them on the homepage at smashomash.com as well as below many of the videos, including this one. So check the links in the description. Support the channel if you enjoy the content. We would prefer to keep it existent, publicly visible, and free for all to view. If you want additional content, consider becoming a member of the Smash Team at smashomash.com/SmashTeam. You can see our Twitch feed there as Twitch is currently streaming. smashomash.com/SmashTeam at the gold or silver level will get you additional content. Even the bronze level, which will cost you $0 per month, will get you additional content. So you can get email alerts. You can get an @smashomash.com email address if you join at the gold level. You can even be informed of the likely mechanism that underlies the sunspot cycles before we even print the paper. So that might be pretty sweet. And we're going to close out the video with Doppler radar and some more U.S. weather data. So there is the full 50-state view. There is the lower 48 view. Let's actually zoom in on these extreme storms here. Some pretty concentrated cells in there. Hey, Georgia, you are in the crosshairs. Anyway, there is clouds and fog. A huge series of cells there. And you can see that moisture being compressed. So what's happening here is it's running into this wall of dry, massive air, creating massive pressure gradients as this relative low has an impulse behind it of additional dry, massive air. So a huge compression happening there. And here's the recap to close out the video. U.S. Doppler radar. Clouds and fog. And the water vapor map, which should clear things up if your Doppler is unclear. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing that the channel exists. And while I'm back in the bunker, may that solar wind